Hello, virtual TrekCon. My name is Mike Wong. I'm an astrobiologist and a planetary scientist at the Carnegie Institution for Sciences Earth and Planets Laboratory in Washington, D.C. And I'm also the host of Strange New Worlds, a science and Star Trek podcast. On this very special virtual TrekCon edition of Strange New Worlds, we are joined by a super special guest, Dr. Marta Cortesao, a real-life astromycologist working at the German Aerospace Center. Marta Cortesao, welcome to Strange New Worlds, a science and Star Trek podcast.
Hello, thanks for having me.
Yeah, it's so great to be able to interview you about your work, which we'll get to very shortly. But the first thing that I always like to ask my guests on Strange New Worlds is about their relationship to Star Trek. So Marta, tell us about your relationship to Star Trek.
So my relationship to Star Trek started very early. It was kind of this family thing that we would watch Star Trek, all together in the living room. And it started pretty early that I understood I really liked sci-fi, and I really liked especially Star Trek, where they would go to other worlds and explore them. And I think that definitely had to do something about my career choice. Because I ended up being a scientist that is exploring something else outside in space. So it's very close to my heart, Star Trek, actually.
Yeah, that's right. I feel exactly the same way. Grew up watching it with my family, and I have no doubt that it influenced my career choice. It's cool to meet people who grew up in different parts of the world who have similar experiences with Star Trek. You're from Portugal originally, right?
Yeah, right.
Yeah, that's so wonderful to hear that Star Trek is this sort of like unifying force around the globe, and you can meet like-minded people who share a love and passion for Star Trek and science.
Yeah, even on the other side of the world. That's crazy.
Yeah, absolutely. So today we're going to talk about astromycology, which is your focus of study that translates to fungi in space, astro being space, mycology being the study of fungi. Before we get into the fun space part, I want to make sure that everybody listening to this and watching this knows what fungi are. So Marta, what are fungi?
Yeah, so fungi, I think maybe if you say the word fungi or fungi, people get a bit confused, but it's actually very simple. We know them from our everyday life. You have mushrooms, which maybe are the easiest ones to identify as fungi. Then you have yeasts, which are the things we use to make our bread, right, or our beer. And then you also have mold, which is also a fungi, the mold you have in your oranges if you leave them out too long, or in your bathroom because there's too much moisture. So fungi are actually these microbes. We classify them as microbes, even though we can actually see them, right? Most of them, we can see them with our eyes. But they are actually microbes that have really complex cells. So they're not so close to bacteria, for instance. They're actually very close to animals, to us, which is even more exciting to think that a mushroom or a mold can actually be close to humans.
Yeah, that is kind of mind-blowing. And as you mentioned, they seem very important to our everyday lives. They're influential in creating the food that we eat. They also degrade things that we produce. In what other ways are fungi super important to the world, and why do you find them so important to study?
Yeah, so I think it's important to understand that fungi are everywhere, like really everywhere. This is something I didn't really fully comprehend when I started researching. But it's like you said, like they contribute to biodegradating like the rest of biomass of organic material that we are and fruit is, for instance. And they actually bring back this organic material into an available form, into nutrients that the plants can take and restart the life cycle. So they're very key players in the whole cycle of life in our planet. And other things that people might also not know, like when you think about fungi, well, besides mushrooms being like an important source of food and other interesting compounds, right? Then you also get mold that is actually being used in biotechnology. to produce antibiotics, pharmaceuticals, vitamins, even plastics they can produce. So yeah, one thing, you find fungi everywhere. You breathe in the air, there's fungal spores. There's no way you cannot breathe them in. And they are very much able to participate in all sorts of different processes across, from biotechnology to degrading, plants. It's incredible.
Yeah, they're everywhere, even in Star Trek. So
Yeah.
central to the plot of Star Trek Discovery is this thing called the mycelial network. And I guess the best way to describe the mycelial network is like a highway through subspace that connects distant regions of space, such that if you have a spore drive, this technology that they've invented in Star Trek, you can jump from one location to another instantaneously through the mycelial network. Now, I've read in various press releases and stories and interviews with the writers of Star Trek Discovery that the mycelial network in Star Trek is loosely based off of this idea that fungi are known to produce something called the mycorrhizal network here on Earth. So what are these real life mycorrhizal networks?
Very good question. Yeah, I mean, in that sense, I was very excited when I saw Star Trek really digging into the fungi world. I mean, first of all, yeah, an astromycologist, like a scientist that actually portrays my job in Star Trek. I was like, whoa, my God, my dream of life has come true.
Yeah.
But yeah, that part of scientifically, Star Trek got that very right, in the sense that it really took what fungi are able to do in the real world. So what happens is that if you see a forest, we know very well that trees grow roots that expand very deep underground, and they branch out and they create this crazy network of roots. But what people sometimes don't really understand, which is normal, right, because we don't really live underground, is that fungi are always there as well. They are the best buddies of plants, of trees. So the same way that trees have roots, fungi also have roots that branch out and expand. And these roots are kind of like the, maybe the streets, or also the highways, like the other lanes of the highway, besides the roots of the plant. And they are also very much helping the plants connect to each other. And this happens in vast, in an extension that is very vast. It can be meters or even hundreds of meters, and they help plants communicate with each other. They help them, transport nutrients and all of these things, even detect, like if there's a bad microbe, a pathogen attacking one plant on one side, then they can send chemical signals to the other plant to start producing compounds that will attack this pathogen. So yeah, these mycorrhizal networks are kind of like the plants and the fungi. They have a symbiotic relationship and they create vast networks. But the important thing is that they are never alone. They're always together. They work together, plants and fungi.
Oh, that's such a beautiful sentiment. And it really gets to the heart, I think, of the idea that the mycelial network helps connect very distant places in space, so that you're never alone. You can always go and find out what's out there in Star Trek. That's really cool. In Star Trek, starships travel through the mycelial network, but I think in these mycorrhizal networks, it's not quite so fancy. There are no starships going
not
through
yet,
them.
unfortunately.
like you said, there are very important things that traverse these mycorrhizal networks here on Earth, from chemicals to nutrients to signaling molecules. Tell us a little bit more about this exchange. What are some of the ways that plants and fungi talk to one another and through each other?
Yeah, so one of the ways is how I said, so they can actually, they are connected chemically, right? There's like a lot of, it's not like a separating, one cell is here and another cell is here. Like they're actually it's a network, but it has a lot of things like a goo outside, right? So it's, all of this is kind of a matrix. Now we're almost getting to another cool movie. You also get into this matrix that is all connected. So even if you think of a highway, it's a bit more than that, because a highway is like you can only go through there and there's nothing happening outside. But there's a lot of incoming traffic, for instance, and there's a lot of molecules that can actually travel all these distances and keep the communication. And one of the most important things is what I mentioned, is this ability to communicate when there's a stressful situation. For instance, that if one plant is being attacked, then the information can travel fast through the signaling molecules into the other plant, which even affects the way they express their genes. Like, oh no, we need to fight against this pathogen. So that for me, it's like the most interesting part, that they can actually work as a team. And if you see one tree, you would never imagine that it's somehow communicating with the other tree, but the fungi also help them do that.
Yeah, that's amazing. These mycorrhizal networks to me really speaks to this concept of interconnectedness between all of the
Exactly.
living things here on Earth, which is another really beautiful sentiment. I was wondering, as a person who studies these phenomenal life forms, these fungi, has it impacted the way that you perceive life on Earth, or just life in general, like what it means to be alive?
Definitely. I mean, I was pretty new when I started researching. I was pretty new to fungi themselves. So I think it's normal, scientists, especially biologists. There's like different things in the in the year 60s. They were very into bacteria, and bacteria were the new amazing things, antibiotics, let's go for it. But then they somehow transitioned to fungi, because they were like, there's antibiotic resistance, we need to search a little bit more. And then they suddenly, okay, now we have all these molecular tools, these new technologies that allow us to see the DNA and the genome. And then fungi started going deeper, and everyone started studying fungi way more. And when I got to there to studying fungi, I was very impressed, because everything I started, digging deeper, and everything I read, there was a fungi being mentioned, or some molecule like pigments, melanin. And I was like, wait a minute, fungi have this, or antibiotics. Wait a minute, fungi have this, fungi had everything across these different parts and areas that are important for our society, industry, and, the like we talked about, like the ecology of the forests, and all, even in your backyard, in your grass, in your flower pot, you have fungi there. And the whole life cycle thing, that they are actually very useful for us, because we all, okay, let's go philosophical, but we're all going to die, right? And then we need to somehow, we are made of stuff and organic material, and this will somehow, like, nature recycles all of that and recycles it through the means of fungi. And yeah, so there's no way of now not how to be impressed by fungi. And then you find out they're actually in the space station, and and then your mind is actually blown away.
Yeah, I know. It's just so amazing to think about how it's not just, these trees that they connect to each other, that they influence through their mycorrhizal networks. They also influence human society so much through, like you said, the development of useful molecules that we use in our antibiotics, and the various other ways, as food stuff, as psychedelics, that they just like really are a part of us, and that we are a part of them too. We're very intertwined through our co-relationship with these fungi. And then, of course, the decomposing aspect, how they recycle everything. I'm not an ecologist, but I can imagine that the recycling of nutrients throughout the biosphere would just be so much less efficient if it weren't for these fungi performing that ecological niche.
Yeah, and then maybe we will get to that later, but also in space, this is a key feature, right? If we're going to live in space for a long period of time, we also need to recycle our waste and our things.
Oh, yeah. I can't wait to hear about that.
Yeah.
Before we get there, let's turn back to Star Trek for a second. So I know that in Star Trek Discovery, it's mentioned that the specific species of fungi that powers this spore drive technology is the Prototaxites stella viatori. Now, I know that Prototaxites is actually a real fungus, isn't it?
Yeah, it's actually a real fungus, although it's not really alive right now. It's like lived from a very ancient period called the Devonian, like 400 million years ago. And
wow.
it was one of the first gigantic fungi that actually, dominated not the whole planet, but at least North America. And it is like one of the first fungi that people were really intrigued about because it was so big. And it really, I think it's interesting that Star Trek writers actually took that one to be the spore drive kind of connecting everything. But yeah, it's a very interesting fungus. Of course, this specific one, the Stella viatori, it's not existing. It was a different one. But I think it's also very cool, the name, because Stella, stars, right? And viatori, like a way to the stars. So it's actually very cool that they give him that name. Him or it. Yeah.
Very aptly named, indeed. Another thing that the Star Trek writers took or were inspired by was a mycologist named Paul Stamets. This was the person who inspired the creator of the mycelial network. Sorry, not the creator, the person who, I guess, discovered the mycelial network and invented the spore drive, Paul Stamets, Lieutenant Paul Stamets in Star Trek Discovery. So the writers named Lieutenant Paul Stamets after this real-life mycologist, Paul Stamets. And so I've always wondered until now, but never knew an actual astromycologist to ask this to, is Paul Stamets the actual mycologist, a big name in the field of fungal science? And what do you know about him?
Yeah, so I actually don't know so much about him besides what as Star Trek came along, I also did some research. But the fungal world is very vast. Like there's a lot of different types of fungi to study. And there's also something very interesting, I think, in the fungal world. You get a lot of people naturally interested in that. So the fungus, like the mushrooms, everyone has kind of a tendency to pick mushrooms, and then they explore the psychedelics out of the mushrooms. And Paul Stamets is a very good example of that, of what we call a citizen scientist. That just naturally is interested and goes and explores. So it's not necessarily like he has a research group and is a principal investigator or any of these things. It's kind of an alternative path to becoming a scientist and an explorer. But it's again like a very different field. For instance, the one that I'm taking right now, which is a bit more traditional, let's say, right, like in academia, and so it's a bit different, the path that we have been taking. But it's very interesting anyway to think that, if you are curious about a topic, that you can go and you can pursue it. And that's, I think, the best.
Mm-hmm. Now, we actually got to meet the actor who portrays Paul Stamets on Star Trek Discovery. His name is Anthony Rapp. And we met him when he came to give the keynote talk at the 2019 Astrobiology Science Conference in Seattle, Washington, which was just absolutely amazing. Like that the NASA folks would invite him to come and give that talk and join us at a real-life professional scientific conference. As I recall, you even asked him a question at his talk. It must have been so thrilling to meet him, to tell him, hi, I'm an actual astromycologist, just like you, but the real version of you. So yeah, tell me what you remember about that event.
Yeah, I remember it being the best day ever because I was so excited. I remember seeing the program of the conference, and I saw that there was this keynote by Anthony Rapp, and I was like, oh my God, I need to be there. But then at the same time, I was traveling from Germany, where I did my PhD, and I was traveling all the way to the US, and my plane landed like 2 hours before. And I was like, oh my God, I cannot be late to this. So I remember being extremely nervous, extremely excited, and also extremely jet lagged. I went directly to the conference venue, no stop in the hotel. There was no time for that. And then when I got the chance to make a question, of course, I was very nervous, but I was also very impressed because Anthony Rapp was just like, oh, really? You're also, like, you study fungi in space? That's awesome. I was like, yeah, isn't that awesome? And I remember I even gave him one of my mugs, because I have like some mugs with I love space microbiology. And
Oh, that's
so
great.
that was great. The chance to meet someone, connected to the Star Trek, that just, living in Portugal, and I was born and raised there, you kind of have this feeling that anything American, like it's very far away, like it's literally on the other side of the world for us. And we have all this access to series and movies, and we actually watch them in the original version, so no dubbing or anything. So we have a lot of connection to that. But of course, when you grow up, you think this is just impossible. You never even think about meeting someone from Star Trek, like, of course, that moment was just incredible. So yeah, I will forever remember that keynote.
Yes, me too. One of the things that I remember impresses me to this day about that keynote was how enthusiastic and excited Anthony Rapp was about our research in astrobiology, and specifically in your research in astromycology. Just the passion and enthusiasm and awe that he brought to meeting you was just as amazing and fervent as your enthusiasm for meeting him. And the fact that they were symmetrical and reciprocal in that way just really warmed my heart.
Yeah, I think that was the best part as well, because you had a room full of scientists, right, meeting this person, this actor, and then we were both sides, right, just so excited and so happy, and with this warm feeling, because we were like, yeah, science fiction actually feeds a lot of what we do. Without that, I would probably not be a scientist. I would not have my mind open to all these possibilities to now go studying mold in space. Who thinks of that? So it was very good that also Anthony Rapp actually had the time and the patience to answer all our questions, and to be very also open to hear what we are doing. That was brilliant. We should do it more often, just bringing sci-fi and scientists together.
I agree. I completely second that. Maybe when you and I organize a conference, we can.
Yes, we should do that. We have a topic already.
Yeah, exactly. All right, Marta, let's turn to your research now. You study how fungi operate in outer space conditions. And I want to first talk about a book chapter that you wrote called Fungal Biotechnology in Space, Why and How. And you write in this book chapter that fungi have been companions of mankind for millennia, and propose that fungi can become important cell factories for life in space, especially regarding the filamentous fungus Aspergillus niger as the cutting edge must-have for space travel in the 21st century and beyond. Oh my goodness, Marta. Of all the things that I think you'd want to pack for a long-term space mission, fungi would be the last thing that I would put on my list. But you say that fungi could be one of the most important partners in space. Please tell me why.
Just tell me more. Yeah, I mean, I understand it would be the last thing that you think about. But one of the biggest challenges in space exploration is actually resources, right? There's one that is also protecting from radiation. So this is like the biggest challenge for life in space. But in terms of human space exploration, going very far away, going to the moon, going to Mars, one of the biggest challenges is resources. Right now, we have astronauts on the International Space Station that is orbiting around the Earth, but it's actually very close to the Earth still. There's a lot of commercial resupply missions that go to the ISS back and forth from Earth to the ISS and bring food and materials and water and whatever they need. So what happens when we go to the moon? Like actually having a habitat on the moon, having these resources, you cannot just go, hey, bring me something. Like it's taking 2 days to get there. Worse, even like when we go to Mars, what happens? Like, oh yeah, I need some antibiotics. Yeah, wait 2 years until I get there, then you're dead. So it's started to think, okay, we need to think about solutions, right? And one of the biggest solutions right now to being explored is the use of microbes. So microbes are actually very lightweight, right? They're actually very robust. They can survive space travel, some of them. And them being very lightweighted, it's actually very attractive, because when you are thinking about space exploration, you want to take things from Earth out of Earth's, gravity pull. And for that, you need a lot of fuel, which means the heavier your rocket is, the more fuel you will need. and it's very expensive, right? And
Yeah.
you also don't want to pack everything you need for 2 years, like in a huge garage. Like you don't have the room or the fuel to get that out of earth. So you need a solution for that. And microbes being very lightweight, it's actually very good. Like with a handful of rice, which has some fungal spores inside, you can actually have a lot of fungal spores. And then once you are in space, once you are in a space habitat or in a moon habitat, you can actually, from this small amount of spores, you can actually grow more. You can grow them and make them, actually have a small factory where they can produce antibiotics. They can also mine the lunar soil. They can actually extract minerals from the lunar soil, and then you can have like a powder of the minerals, like aluminium, for instance, that you can use them to maybe 3D print something. I don't know. So it's kind of like completely amazing to think that, just from one fungi, so this fungi, fungus Aspergillus niger, it's very used right now in industry. There's like millions of euros or dollars put into growing this fungus to actually produce a lot of these compounds, even plastics they can produce. And it's a cellular machine. There's like very complex machinery in terms of molecules and the genes that they have, and you can kind of fine tune that into producing basically whatever you want. So anything you can think about, you can almost, for sure, you can fine tune the fungus to produce. And this is very interesting. Like it's flexible, it's easy to grow most of the times, and you can basically produce whatever you want. So yeah, why not bring a piece of mold with you to the moon or to Mars?
Amazing. This is like, utilizing one of nature's best engineers. And I would have never guessed that one of nature's best engineers was a fungus, but apparently, like you said, it's used all over industry and could be super useful in space because of its, well, for one, lightweightness and its ability to adapt to space environments. So that's been another line of your research, trying to understand how this particular fungus can survive in outer space. And so in a study published in Frontiers of Microbiology in 2020 and another in the same journal in 2022, you found that the spores of Aspergillus niger are highly resistant to space radiation and that they grow in microgravity. Tell us about these studies. How did you do them? What did you find? And what are their implications for space exploration?
Yeah, so one of the biggest challenges, as I said, is space radiation. And this is impacting astronauts, of course. Astronauts cannot really stay much longer than 6 months, 1 year in space, because if not, the radiation can really start to damage your own cells. And when we think about space travel, there's also this thing of planetary protection, right? Like, can our microbes, if we go to the moon, can our microbes also go to the moon and survive space? Or if we go to Mars or we send a rover to Mars, can the rover take some microbes with the rover and then contaminate Mars? And we really wanted to know, in this sense, if Aspergillus niger spores, because spores are very resistant. They are known to resist very extreme conditions, temperatures. We wanted to know, how resistant are they? Could they survive space travel? Could they survive from here to Mars, for instance? And what we did was exposing them to different radiation types. So in space, radiation is in a lot of different forms. It's ultraviolet radiation, like the one we have from the sun. It's also X-ray radiation, which also comes from the sun. And then you also have cosmic radiation, which are different particles that come from like remnants of supernova explosions, for instance. They are also very hard to shield. And so we expose them to these different kinds of radiations with very high doses of radiation. And what we found was that the spores actually survived. Of course, this was like a one-hit dose, like, okay, let's see if they survive. It's not like a long-term low dose kind of thing, but they survived, and they survived very high doses, up to 1,000 gray, which is the dose we use for cosmic radiations, for instance, and X-rays. So how incredible is that, to think that spores like fungal spores, just put them on a rocket, stick them in a rocket, send them to Mars. When they go to Mars, they will survive. So, and this is mainly because they actually, so the spores have very thick cell walls and they have a lot of pigments around. You asked me to bring some visuals. I don't know if we should share
please.
them now or.
Yes, I would love that. Yeah.
Sorry, I was like, okay, maybe we should start with the visuals. Let me share my PowerPoint. Can you see it?
Yes, yes.
And can you see?
I see a mycelium network,
Yeah.
vegetative mycelium. Yep, okay.
Perfect. Okay, and you see my mouse? No.
I do, yes.
Ah, perfect. Yeah, so this is like fungi on the space station. Yay. So they basically took that panel out and took them off board, to burn into atmosphere re-entry. And this is kind of what a colony of mold, like when you look at a mold in a wall or something, you see this. And this is how they grow in a petri dish, for instance. And if you kind of cut a slice out of this fungus, what you see is this is like a huge mycelium network here that they use to actually attach to the walls and attach to the agar of the petri dish. And then they have these structures here that form the spores. And you can see here the mycelium network is a very interconnected complex full of cells. Every small round thingy is a cell. And what is interesting is that they also form these spores. And these spores, here you see they are very black. And they have all this pigment here in the cell wall. And one conidiophore, one of these heads of piece of mold forms all of these spores. And the higher they go here, the easier it is to release these spores into the environment. So they can form millions of spores, and then they go all the way through the air. They can easily release and disperse to then, attach different surfaces, colonize different habitats. You can inhale them. And usually your immune system is totally fine with that. But this was what we tried to kill. So these spores. And one of the, okay, maybe we're not going to go there now. With Mars, we're going to the radiation, right?
Sure, but yeah, whatever you think is best. You can tell us about this experiment here, or you can proceed with the radiation. Up to you.
Yeah, so this is connected. So the thing is that we wanted to know if they survive space travel, so from here to Mars. And then this is also impacting like radiation and extreme temperatures. And what we did in one of the experiments was actually sending Aspergillus niger spores, these very, these ball spheres. We actually send them on a balloon, on a scientific balloon in a mission together with NASA. So it was a DLR NASA collaboration. And we send them to the stratosphere for 5 hours, 38 kilometers altitude. And we had temperatures varying from minus 51 degrees Celsius to plus 21. And what is interesting is that this stratosphere is actually a Martian analog. So if you think of Mars at the equator, it has a very thin atmosphere, but it also has ultraviolet radiation levels that are very similar to the ones we find in Earth's stratosphere. So it's crazy. Of course, it's not the same thing as sending, a bunch of spores to Mars and seeing if they survive, but it's a very valuable analog, which is way cheaper, is way faster, and is way faster to achieve. So what we did was actually putting these spores, we tested 2 different things. So here you see the spores, like imagine this as being attached to a rocket, for instance. Could be that you have a lot of spores and you have like a bunch of them on top of each other, or it could be you just have 1 or 2. What is the best way? Would they survive just if they're like protecting each other, group? Or would they survive if there's just one spore very lonely traveling to Mars? Would it survive? So we put them in these discs, and we actually put them in this vacuum chamber that we then filled with Mars gas, with Mars artificial atmosphere. And then we put them on the balloon. And one of the cool things is this video. You can see the video?
Yes, it's playing. Oh, it just opened and it's exposing the spores
Yeah.
to the radiation.
Yeah, so this thing is a scientific balloon. Here is the payload. Here is the Mars box with all the different, we tested different microbes, but one of them was this fungus, Aspergillus niger. And once it reached 38 kilometers altitude, it opened the shutter to expose them to all the radiation. So there's this glass that is not filtering any of the radiation. And then it stayed there for like 5 hours roaming around the stratosphere. And then when it was ready to go down, the shutter closed. So we have for sure like 5 hours of intense radiation. And then the balloon went down and we recovered the samples and see if the spores survived or not. So what we found was actually that even like lonely spores not protected with each other, in the top layer, which is this one that is here being exposed to all the radiation, they actually still survive. They have a bit of, so this is survival. Here they survive a lot, and here, for instance, they don't survive as much, but there's still a lot of cells, a lot of spores that could actually survive. And this, of course, this like, yeah, what we kept some of the spores in a lab and some of the spores on the bottom layer that didn't have any radiation, but they actually survived, which is crazy.
So what I see from this is basically the lab control for the survival and the bottom layer are fairly similar. So the spores that were on the bottom, buried underneath other spores, basically didn't get harmed by the radiation at all. No. And some of the ones on the top layer did, but there were still some that survived. And that's pretty impressive.
Yeah, and what you can see from here as well is that the bottom layer pretty much still has Mars atmosphere, and it was still exposed to the variation of temperatures from minus 51 degrees Celsius to plus 21. So imagine there's spores on Mars, but shielded by some kind of soil, you know, or from the rover. They're like on the bottom of the rover. They would be okay with living on Mars, well, living or at least existing on Mars. Whether they reproduce afterwards, this is a different story, but at least they would survive. So if we would go there and try to detect some life, maybe you would find a spore. Who knows?
Yeah, this is really incredible. Did you have any other figures and animations to show us, or
so that's pretty much it.
Okay.
And I also had this, which I forgot to show you.
Oh my gosh. Okay. Stamets, Prototaxides stellaviatori. That's great. So this is actually a slide that you would show during some of your scientific talks?
No, but I will show them from now on. I will show
now,
the
of course.
slide.
Okay, yeah. For special for Virtual TrekCon, everybody.
Exactly.
Yeah, I love it. Yeah, so this is what Prototaxides, the real Prototaxides is what we're seeing here on the right-hand side. Is that right? Sort of like an artist impression of what they would actually look like?
This is kind of the closest to the fossils that they found, which was a pretty big fungus. And in the beginning, they didn't know if it was a fungus or if it was a cyanobacteria or a plant. And this is the artist's impression. And there's 2 videos that I think really explain like what they think it was. So that was pretty nice.
How big did it get? It looks like it's quite large in these artist depictions.
They set up to 9 meters, I think.
9 meters.
There were pretty much no trees back then, or they were like bushes, but not very big trees, and fungi really dominated. Yeah.
And I guess the reason why they're growing so high is so that, like you said, the higher they get, the better dispersal of their spores.
Exactly. So imagine a bunch of spores just going, wind of spores. Yeah. Wow. Good thing there were no humans back then.
Incredible. Yeah. 400 million years ago, no trees, no humans. It was a fungal world, I guess.
It was a fungal world.
Amazing. I would love to see a world like that in Star Trek Discovery, just populated by fungi. Maybe the home world for Prototaxides stellaviatori.
Oh, that would be great, exploring that home world.
Yeah, great. Okay, well, thank you for bringing these excellent visuals. That really helped, I think, explain the science and your research in particular. I just have a few last questions for you, Marta. You mentioned how you've discovered how radiation resistant these fungal spores are, how they can survive Mars-like conditions. What do you think the implications are for the idea of panspermia, that life could hop from one planetary body to another, not necessarily like on our rovers, which you said if it can probably do, but just like seeding other worlds with life and starting biospheres from an asteroid that was blasted off one planet with life and then brought it to a completely new barren world and gave it life.
Yeah, so I think as we are now studying more and more microbes, and we understand that they're actually very resistant, maybe way more than we ever imagined. Us humans are very vulnerable. We are fragile compared to microbes. Shame on us. So yeah, I think it's really an hypothesis that is worth considering. So of course we cannot prove it yet, and maybe never, but knowing how resistant these fungal spores are, or even other bacterial spores, and knowing also how planets are formed, that our solar system also had a lot of exchange. We had a lot of asteroid collisions, and then you have a piece of rock that goes away and is beamed off, and can actually bring a lot of this organic material. We also know that a lot of asteroids have organic material already, whether there's microbes or complex life. And complex, when I mean complex, is actually like a cell, and the fungal spore is very complex. I'm not meaning like a little green man or something.
Yeah.
But asteroids and comets have organic elements, and this means that there is a possibility there's maybe some life form, at least a very primitive, a very minimal cell with some DNA in it. And this is something chemists and biologists and biochemists are exploring a lot. And the more we also, explore and develop technology that helps us go to other planets and go to these asteroids, land on the comets and take samples and see what's actually there. And this is where it gets really exciting, because we are there now. We are there. We can actually send stuff, land, take samples, read them out, and find, oh yeah, there's an amino acid here. Amazing. Like amino acids, this is what our proteins are made of, and we can find them somewhere in space. So this, of course, brings the question, like, why not some life just going from Earth and all the way to Pluto, or maybe another solar system. That's maybe a bit more complicated, a lot of travel, a lot of radiation from here to another solar system. But at least within our solar system, that's actually pretty possible as far as we are now understanding. And there's also this theory, right, that we all are Martians, that we came from Earth, because Mars also, geologically is like an older Earth. When we see Mars, we look at the future of Earth. So it's a bit smaller, so it's kind of evolved a bit faster than Earth. So what if, there was some life from Mars that hit, through an asteroid and hit Earth and kind of seeded our world? It's also one of the origin of life theories, but who knows? We don't know. I think we will never know, because it's hard to go back in time and be there. But it's very interesting.
Yeah, absolutely. I guess in addition to a spore drive, what we need from Star Trek is also a way to time travel. And then maybe we will find out how life originated on Earth or on Mars or somewhere
on
else.
Mars. Yeah.
I guess one thing that I wanted to ask, just given all of this amazing knowledge that you've bestowed on us today about how absolutely incredible these spores are, how resistant they are to harsh environments, why would they be evolved to be so resilient that they could survive in space? Is it because of part of their fungal distribution mechanism that maybe through the wind they do get blown up into the stratosphere, and so therefore there's a selection pressure that selects for those that can survive there? Or why are they so extreme tolerant?
Yeah, well, if I knew 100% the answer, then I wouldn't need my job to investigate. but there's a lot of possibilities, right? One is what you said, like evolution wise, they were kind of selected and pressure to actually evolve these ways of repairing their DNA very efficiently, to have these pigments around the cell wall so that they can resist radiation. But what we also know is that, for instance, the pigment, the melanin, the same pigment that they have in the cell wall, the same pigment, well, a bit different, but the same pigment that we have in our skins and help us also not get sunburn. It's the pigment that the spores have and helps them resist radiation. But this same pigment is also the molecule that helps them, resist and communicate with plants. Like there's one molecule that has different roles in the cell. And another thing to consider also is that, for instance, when you think about resisting harsh conditions, one of the main things you need to think about is repairing the DNA. Everything depends on how well your DNA is. So if you can protect your DNA, like with this huge cell wall and the pigments, then your DNA is not going to get damaged and you will survive. But if your DNA gets damaged, then you need to find a way to repair it. And these repair mechanisms that fix the DNA after it's damaged by the radiation, they can also come from other places. They can come from, resisting very high temperatures. Very high temperatures also can damage your DNA. And maybe they evolved in some way, with very high temperatures. And then it's like by chance that they actually resist radiation. Or most likely it's also because of, dispersing through the atmosphere, reaching these high levels of radiation. The higher you go, if you go up the stratosphere, you don't have ozone layer anymore. It's your protection to the radiation just finishes there. So if they found a way to disperse, especially in this very ancient world, the Devonian period, 400 million years ago, they would have to survive radiation for sure in order to disperse. So it's very interesting.
Yeah, absolutely. What amazing creatures. And I think what you were getting at in your answer to my question was this idea of exaptation, right? That perhaps the evolution of one function or, like you were talking about the heat resistance could then also serve another function, which is radiation resistance. That's super cool. Yeah. Well, Marta, I really hope that the Star Trek writers are listening right now and are getting so inspired by you that they will name a character after you in Star Trek, just like they named someone after Paul Stamets. If that actually comes to pass, what would Lieutenant Marta Cortesao study in Star Trek? What kinds of science questions would you like to what kinds of science questions would you like to ask in the Star Trek universe?
Yeah, so first of all, if you do that, the writers, I would die of happiness. But I think I would love the character to actually be like, of course, an astromycologist that goes in different worlds and explores the potential of fungi, and then has all these different gadgets, fun technology gadgets with all the different things and potential that fungi have. Like imagine find out a fungi that can cure a very weird alien disease, or that can produce food whenever you need it, or maybe even, finding out what fungi can do, but maybe they can also have a spacesuit made out of fungi because they protect so well from radiation. Maybe there's like the best spacesuit ever is like designed by Lieutenant Marta Cortesao. That would be great. That would be great.
I love it. I mean, basically that's what you're doing already. So, I mean, I've got to hand it to you. You are living in Star Trek right now by studying astromycology. So that's so cool. I'm sure that everybody watching this is going to want to keep up with all of your cool research and all of your great science communication. So my last question for you, Marta, is where can people find you on the internet?
Well, you can find me pretty much everywhere. So Instagram, Facebook, LinkedIn, ResearchGate also, and Twitter. So either Google my name, Marta Cortesao, or Space Microbes. Also a website, spacemicrobes.com. And yeah, so anything, drop me a message.
Great. Thank you so much for being on Strange New Worlds. This has been a long time coming. I learned so much from you today and just had a blast. So thanks again.
Thank you, Mike, for having me. It was my pleasure to be here.
And thank you all at Virtual TrekCon 4 for watching this special video episode of Strange New Worlds, a science and Star Trek podcast.